Hello student. In previous class we have discussed about the simple assembly language program of addition, subtraction of two 8-bit number, block of data transfer. So today we will discuss about the largest and smallest numbers in an array. So to find the largest number in a data array, the algorithm is like this. First step 1 is store the count in the memory location pointed by HL register. So first in HL register we have to store the counter value. In step 2, move the first number of data array into accumulator. So the first number first store in accumulator. Next, step 3 is compare this with the second number in memory location. That means we have to compare the first number with the second number. In step 4, the larger in the two is placed in accumulator. That means among these two numbers, first number and second number, which is largest, that larger number is placed in accumulator. Next, step 5 is the number in accumulator is compared with the next number in memory. That means the number which is present in accumulator, that should be compared with the next number which is present in the next memory location. Then step 6 is the larger number is stored in accumulator. That means among these two numbers, which is the largest, that number is stored in accumulator. Step 7 is the process is repeated until the count is 0. Suppose we have to take the count value 10. So until the count value is 0, we have to repeat the process. Then step 8 is the final result is stored in the memory location. Next, step 9 is stop the program. So this is the algorithm for finding out the largest number in a data array. Next, to find the smallest number in a data array. So for this the algorithm is first step 1, store the count in the memory location pointed by HL pair. So first we have to store the counter value. Step 2 is move the first number of the data array into accumulator. First number is stored in accumulator. Step 3 is compare this with the second number in memory location. That means the number which is present in accumulator, that must be compared with the second number which is present in the next memory location. Next, step 4 is the smaller in the two is placed in accumulator. Between the two number, which is smaller, that must be placed in accumulator. Means the result, the smallest number is placed in accumulator. Next, step 5 is the number in accumulator is compared with the next number in memory. That means the smallest number which is present in accumulator, that must be compared with the next number which is present in the next memory location. Next, step 6 is the smaller number is stored in accumulator. Number 7 is the process is repeated until the count is 0. That means until the count value is 0, we have to repeat the process. Next, step 8 is final result is stored in memory location. Next, step 9 is stop the program or halt the program. So this is the program for algorithm for finding out the smallest number in a data array. Next is memory and IO addressing, means memory and input output addressing. So in memory mapped input output, we allocate a memory address to an input-output device. Any instruction related to memory can be accessed by this input-output device. The input-output device data are also given to the arithmetical logical unit, that is ALU. So this is memory mapped input-output. Next, input-output map input-output. We give an input-output address to an input-output device. Only in and out instructions are accessed by such devices. The ALU operations are not directly applicable to such input-output data. So this is all about your chapter 2, that is simple assembly language programming. So I hope that the entire video of chapter 2 are understanding by all the students. So thank you.